Hello guys, hope you all are doing well. So in the continuation of the previous GATE series, we are solving questions from GATE 1996 section B. So today we will uh, solve few more questions, and in the next video we will complete 1996. Okay. So very first question, solve dy by dx plus 0.65 is equal to 6 e power minus 0.5 x. So this is the differential equation, and we know that what is the type of this equation, dy by dx plus py is equal to q. Okay, so we have to solve. This is the initial boundary condition. So integrating factor will be E is equal to P dx. Okay, so E is equal to P is 0.6 dx. So integrating factor will be e to the power 0.6 x. Okay, now solution of this kind of equation is, you know, y into integrating factor is equal to q into integrating factor dx plus c. So this is the solution of this kind of equation. So y integrating factor is e to the power 0.6 x, q is 6 e to the power minus 0.5 x into e to the power 0.6 x dx bracket plus c. So y e to the power 0.6 x is equal to 6 integration e to the power 0.1 x dx plus c. Okay, so y e to the power 0.6 x is equal to 6 e to the power 0.1 x upon 0.1 plus c. Y e to the power 0.6 x is equal to 60 e to the power 0.1 x plus c. Okay, I will write here y is equal to 60 e to the power 0.1 x minus 0.6 x plus c e to the power minus 0.6 x, right? This will be the equation. Just simple mathematics. E to the power minus 0.1 x, sorry, 0.5 x, 0.5 x plus c e to the power minus 0.6 x. Okay, at y1 at x equal to 0, 60 plus c. So c will be minus 59. Okay, so put value of c here, you will get the solution, and this is the solution. Okay, so straightforward question. Question 59. Methanol vapor can be converted into formaldehyde. These methanol into formaldehyde by the following reaction: oxidation and decomposition. The fresh feed to the process was 0.5 kilomole per hour of O2 and an excess methanol. Okay, so methanol quantity we don't have in the fresh feed. So okay, all of the O2 react in the reactor. O2 completely reacted. Okay, formaldehyde and water are removed from the product stream first, after which H2 is removed from the recycled methanol. Okay, so there is only methanol left in the recycled. The recycle flow rate of the methanol is 1 kilomole per hour, and it is given. Ratio of methanol reaction by decomposition. Let one, sorry, let this will be 1 and this will be 2. Reaction. Decomposition to that of oxidation is 3. Draw the flow diagram and then calculate the per pass conversion of the methanol and the fresh feed rate of the methanol. Okay, so very first thing we see, what is per pass conversion. Per pass conversion and overall conversion. What is difference? Overall conversion. Okay, for that we have to draw the diagram. So suppose this is the reactor in which these two reaction is taking place. Reactor, this is F. In F we have 0.5 kilomole per hour O2 and x kilomole per hour of methanol, CH3OH. Okay. Now, after that, there could be a separator to separate the product and the unreacted reactant. So, separator. Then it is recycle. So, this is mixed feed. This is recycle, and separator separates the uh, HCHO, H2O and H2. The recycle is only CH3OH, which is 1 kilomole per hour. Okay. So per pass conversion means on the basis of limiting reactant. So here's methanol. So methanol in the reactor feed of the reactor here, methanol at the end of the reactor, exit of the reactor, and upon the feed of the reactor. So per pass conversion on the basis of limiting reactant. Suppose limiting reactant is A. So methanol is A. Suppose methanol is A. So A in M minus, what is the quantity of A in M? A in exit of reactor, reactor. This is the exit of reactor is this stream divided by A in feed of reactor, that is M. Feed of the reactor is this stream, that is M. Okay. Overall conversion means A in fresh feed, that is F, minus A in product, that is product. This is the product. This stream is the product divided by A in F in the fresh feed. So this is the difference between per pass conversion and overall conversion. So we have to calculate the per pass conversion. Okay. So I will erase all this. Okay. Now, so we have, now I will write like this: reactor, separator, F 0.5 kilomole O2, X kilomole CH3OH, R is equal to 1. This is recycle and this is reactor. Okay, and this is HCHO, H2O and H2. Okay, now very first see the fresh feed to the process 0.5 kilomole per hour of O2. Okay, so CH3OH reacted by the reaction 1. CH3OH reacted by reaction 1 is equal to 1 by 0.5 into 0.5 is equal to 1 kilomole. Okay, 1 kilomole. Okay, now the ratio CH3OH reacted by decomposition by reaction 2 divided by CH3OH reacted by reaction 1 is equal to 3. That is the ratio given. So this quantity we have, that is 1, just we have found. So CH3OH reacted by reaction 2 is equal to 3 kilomole. Okay, total CH3OH reacted is equal to 1 plus 3 is equal to 4 kilomole. and same, this is the same quantity SCHO produced. Okay, so X kilomole, sorry, CH3OH in fresh feed is equal to X, CH3OH in recycle 1. So M is equal to X plus 1, right? Since total CH3 reacted 4 kilomole, and this is the CH3OH, total CH3OH reacted 4 kilomole, this is the CH3OH in the feed. So CH3OH unreacted equal to feed minus reacted, X minus 3. And since this is unreacted, this is the quantity only which will be recycled. So it is equal to 1. So X is equal to 4. Okay, so X is equal to 4. X is equal to 4 kilomole. 4 kilomole. So see, per pass conversion means per pass conversion is equal to, what is in feed? 5. How? 1 plus 4. 4 plus 1. Okay, minus 1 in the output of the reactor, that is the recycle, divided by 5. So is equal to 4 by 5, 80%. 80% per pass conversion, and fresh feed rate of methanol is 4. Okay. So if you have any kind of doubt, anything, just comment it below. I'll try to reply as soon as possible. Okay. So this question, water trickles by gravity over a bed of particles. So suppose we have this bed of particles. Okay. We have particle. Okay. And water is trickling from a, like this, water is trickling. Water trickles by gravity over a bed of particle. Each 1 mm dia in bed particle, diameter of particle is 1 mm, and bed dia, diameter of bed, that means 6 centimeter, height is 2 meter. 1 mm is the particle diameter. The water is fed from a reservoir whose diameter is much larger than the packed bed. So diameter is very large. Suppose very large. Water is trickling down. With water maintained at a height of 0.1 meter, is the height above the top of the bed porosity is, calculate the volumetric flow rate of it, volumetric flow rate of water if its viscosity is this. Okay, so very first thing, to calculate the volumetric flow rate, Q is equal to area into velocity. Question saying that diameter is very large. If diameter is very large, then see, Q is equal to pi d square by 4 into velocity. Okay, so diameter is very large, so velocity will be 0. If diameter is very large, then velocity will be 0. Okay, and if there is a something value of diameter, then it is not given in the question what is the value of the diameter. Okay, so some data is missing in this question, but we can calculate the volumetric flow rate through the bed. How? We know that del P is equal to G 1 minus E rho P minus rho F into L. This is the only equation we could apply in the packed bed reactor, but it is for fluidization, just fluidizing the bed. But for specific particular this question, I feel that some data is missing. Okay, so pressure drop will be G 9.81, 1 minus 0.31, rho P minus rho F. Fluid density is not given, and what fluid, sorry, particle density is not given. Fluid density we have water. Particle density is not given, so what we can use as particle density? Okay, so there is a problem in this question. Okay, so if you have solution of this question, just share it with me. Okay, so suppose I have a particle of density 2000 minus 1000 into length is 2 meter, so it will give value 13537.8. Now if I apply Bernoulli equation at this point and this point, okay, I can apply Bernoulli equation at this point also and this point also. Okay, but what could be the pressure at this point is not specifying. Okay, even if we will find del P, it is difficult to find the volumetric flow rate. Okay, so we will apply at this point, at this point. So now applying Bernoulli equation at point 1 and 2. So P1 by rho G plus P1 square by 2G plus Z1 is equal to P2 by rho G V2 square by 2G plus Z2. So V2 will be 0. There is no velocity at the bottom. Okay. So V1 square by 2G is equal to P2 minus P1 by rho G plus Z2 minus Z1 is 2. So V1 square by 2G, if you will calculate this by putting del P is this, P1 minus P2 is this, put this value, so you will get divided by 10 to the power 4 to 1.353. Okay, plus 2, 3.353. So V1 square is equal to into 20, 3.353 into 20, 67.67, and when you V1 is equal to 8.2 meter per second. Okay, so Q is equal to area into velocity. So area will be pi d square by 4 1 minus E, because E is the porosity and the remaining E is the porosity of the particle, porosity of the bed. E is the porosity of the bed. Bed has the porosity. Into E. E has the porosity of the bed into velocity 8.2, because the water will pass through the pores only. Okay, not with the. So after solving this, you will get the volumetric flow rate through the bed, which is going down. Okay, so you can leave this question. I feel that this question is important because it is on fluidization or related. The GATE has tried to merge few concepts, so it is up to you. Question 61. This is important. Ammonia at atmospheric pressure and 300 Kelvin. So NH3 at P atmospheric and 300 Kelvin with a bulk stream velocity 10 meter per second flows through a pipe of internal diameter 0.25 meter. Calculate the pressure drop per 100 meter length and the power consumed. Friction factor is this. turbulent regime, viscosity of ammonia may be taken as this. Okay. So very first thing, HF is equal to 4FLV square D into 2G is equal to del P by rho. Okay, take these two. You will get del P is equal to G and G will cancel out. Del P by rho is equal to 4FLV square 2D. Now, F is equal to 0.079 into Reynolds number, rho Vd upon mu, divided by minus 0.25. We don't have the density of ammonia, so we will calculate density of ammonia NH3 is equal to Pm upon RT. This is the value to find the density of a gas, 101.33 kilopascal, 17 kg per kilomole, 8.314 kilopascal meter cube kilomole into Kelvin into 300 Kelvin. So you will get kilopascal, kilomole, Kelvin, you will get 0.69 kg per meter cube. Put this value here, you will get F is equal to 0.004, I think. Okay. Now del P, when you will put all the value, this is density of ammonia we just have found. So you will get del P 311.6 after putting all the values. Okay. Everything else we have. Okay, length, velocity. Now power required is equal to rho G Q HF. HF is del P by rho G. Rho G and rho G will cancel out. So Q into del P. So Q is area into velocity into del P. So when you will put all the values, you will get 153 watt. Okay. 0.15 kilowatt. Okay. So straightforward question. Okay. A thermocouple junction may be approximated as a sphere of diameter 2 mm with thermal conductivity, density and specific heat. Heat transfer coefficient between the gas stream and the junction is itna. How long it will take thermocouple to reach the 98% of the applied temperature? Straightforward question. T minus TA, T minus TA, Ti minus Ta is equal to e to the power minus Ha upon rho V Cp. See, initial temperature will be Ti and the atmospheric temperature Ta. So while putting the sphere in atmospheric temperature, from initial temperature to atmospheric pressure, how much time it will take to reach 98% of the applied temperature difference? That means 0.98 of the Ti minus Ta. This is the value of this T minus Ta. So 0.98 Ti minus Ta divided by Ti minus Ta is equal to e to the power minus h upon rho Cp. I told you V upon A is the characteristic length in case of sphere is equal to R by 3. So put here R into 3. Okay. 0.98 is equal to e to the power minus h is what? Heat transfer coefficient. That is the heat transfer coefficient 280 watt per meter square degree Celsius into 3 divided by rho density at 8600 kg per meter cube. Cp is 0.4 into 1000 joule per kg degree Celsius and into radius. Radius is 10 to the power minus 3, because this is diameter, radius will be 1 mm, 1 mm is equal to 10 to the power minus 3 meter. Okay, now see, meter square and this meter will be meter cube, cut it by meter cube, kg and kg will cancel out, degree Celsius will cancel out. Okay, this what we, joule per second I can write, so joule and joule will cancel out. Okay, now only second has left, so this will give the time into t. I forgot to write t into t. Okay, so solve this question and you will get t. Okay, straightforward. This question is little bit long and important. So a shell and tube steam condenser is to be constructed of, very first thing, so suppose the inner diameter is 0.022 meter and outer diameter is 0.025 mm. Okay, now see, we know that the temperature profile for if the steam is condensing, then this will be 54 degrees Celsius. Cooling water, you can take any side, LMTD will not change. So outside of the tubes and cooling water enter 20 degrees Celsius and out 36 degrees Celsius. 1 kg per second is the flow rate. The heat transfer coefficient for the condensation is heat transfer coefficient for the condensation of steam for this H outside is equal to 7900. Calculate the tube length. If the latent heat of condensation 2454 kilojoule per kg, calculate the condensation rate per tube. Okay. The properties of water flowing inside the tube will be this, and heat transfer. So H inside will be come from Dittus-Boelter equation. This is the Dittus-Boelter equation. So very first thing, Nusselt number HL upon K is equal to 0.023. Reynolds number is rho VD upon mu 0.8. Prandtl mu Cp upon K 0.4. See, Reynolds number equal to rho VD upon mu. Velocity we will not found. What we will do? Rho d by mu. Velocity we can write 4q upon pi d square. So 1d will cancel out. Rho, this rho and this q will become the mass flow rate. So 4 mass flow rate divided by pi mu d. And mass flow rate we have 1. 4 into 1 divided by pi mu we have 0.86 into 10 to the power minus 3 into diameter 0.022. So Reynolds number will be okay. So the Reynolds number will be 4 divided by pi divided by 0.86 divided by 3 minus 10 to the power divided by 0.022. 67295.96. Okay, so putting this value here and we will calculate, put all the values, you will get H is equal to 9444 watt per meter square Kelvin. Now I told you what is the formula for overall heat transfer coefficient based on the outside D naught 1 upon H naught Hi di plus 1 upon H naught D naught. The resistance of the tube will be negligible. Okay, so U naught is equal to 1 upon D naught 0.025, 1 upon H naught will be H naught, H inside, sorry, H inside we have calculated 9444, this is H inside, that means tube, into 0.022 plus H outside we have 7900 into 0.025. After calculating this, you will get U naught is equal to 4050 watt per meter square Kelvin. Okay. Kelvin. Okay. So applying energy balance, heat gain by cold fluid is equal to U A theta m, U pi dl theta m. Okay, theta m will be 54 minus 20 minus 54 minus 36 divided by ln 34 by 18. It will give 25.2 degrees Celsius. So mCp delta T of cold is equal to 4050 into pi 0.025 into length we have to find into 25.2. m is 1 into 4180 into del T 36 minus 20 is equal to, so 4050 into pi 8015.77 L into 4180 into 8.34. So length is equal to 8.34 meter. So this is the length, and condensate rate will be very simple. This heat gained by the cold fluid 4180 into 36 minus 20 divided by the, this is in kilo, sorry, um, this is in joule per second, and this 2454 kilojoule per kg. So it will come in kg per second. So this is kilo, so into 1000. So joule and joule will cancel out. It will give 0.027 kg per second. Okay, this is the condensate rate. Okay, so the next question is 990 kg per hour of aqueous solution has a solute at a concentration of 0.1 kg solute per kg water. It is treated with 600 kg per hour of pure immiscible organic solvent in a two-stage mixer settler system. If the organic and the aqueous stream leaving each other are in equilibrium such that kg solute in organic phase, kg solvent is equal to kg solute in aqueous phase of kg water. So aqueous phase is this, so y is equal to 2x. Why? Because x is kg solute in kg water, feed solvent. Calculate the kg solute extracted per kg solvent if counter current operation is employed. So very first thing, suppose this is stage 1 and this is stage 2. Okay. Counter current operation, so solvent will be Okay, so we have A plus C. C is the solute is equal to total 990 kg solution per hour. This is solution per hour. See, x1 is, this is mole ratio 0.1 kg solute upon kg solvent. So small x1 will be 0.1 divided by 1.1. If I multiplied 990, then it will give value of solute, kg solute. So 900 will be solvent only. So 900, 900. 600 solvent, feed solvent. This is 900 feed solvent. This is extracting solvent 600. Don't get confused. 600 kg solvent per hour. Okay. Now this is, sorry, this is x naught. This is x naught. This will be x1, which is coming from the stage 1 will be x1. This is coming from the stage 2. So this is y2. This is coming from stage 1. So y1, and this is y naught. This is x2. Okay. Now, sorry, this is y1. Okay, so y2 will be 0 because the solvent is pure. So apply solute balance on stage 1. So 0.1 into 900. See, 0.1 is kg solute upon kg solvent, and 900 is only the solvent. So solvent will cancel out. This is the quantity of solute only. So solute balance. This is going in. This is going in. So 600 y2 is equal to 900 x1 going out from the stage 1, and 600 y1 is also going out from the stage 1. Stage 2 balance. So this, if you will solve further, 90 plus 600 y2 is equal to 900 x1 plus 600 y1. Stage 2 balance if I will apply, then 900 x1 is going in plus 600 y mark y naught, because we have mark inside as naught. Okay, so y naught is equal to, both are going in, and 900 x2 going out and 600 y2 going out. Okay, so this will be 0 because y naught is 0, solvent is pure. So 900 x1 is equal to 900 x2 plus 600. Now y2 is equal to 2x2, I can write. Y2 is equal to 2x2, I can write. So I will replace here 2x2. So if you will solve, x1 is equal to 2.33 x2, right? Put this value of x1 here. Okay, you will get, I will solve here, 90 plus 600. y2 is 2 into x2. 2x2 is equal to 900. x1 is 2.33 x2 plus y1 is 2x1. 2x1 is 2.33 x2. So 2 into 2.33 x2. So from here x2 is equal to 0.0243. This x2 will be this 0.0243. If you will multiply this is kg solute per kg solvent into 900 kg solvent. So solvent cancel out, you will get the value of solute, that is equal to 21.89. Since we have fed with 90 kg solute and remaining is 21.89, so kg of solute extracted 90 minus 21.89, 68.41. 60 I can write here. So 60. So this y1 should be 68.41. Let's see what will be the value of y1 come. Y1 come from here. So 2 into 2.33 into x2 is, x2 we have called 0.020243. So 2 into 2.33 into 0.0243, 0.113238, 0.11. Y1 is here. Y1 is capital Y1. 0.113238. If I multiply with 600, 67.9. So see, almost 68, almost equal. So this is the amount solute extracted per kg solvent. If you want to calculate this, so 68 kg solute 68.41 divided by 600 kg solvent. So this is the value of required value. Okay, 0.1132. So if you have any kind of doubt, anything, just comment it below. I'll reply as soon as possible. Okay, bye guys. There are few questions remaining. I will upload by tomorrow. Okay, then we'll start 1997. Then up to 2002 we have to solve, because up to 2002 there will be subjective question. Then we will go for objective ones. Okay, so bye guys, take care.